Today we're going to start talking about factoring a greatest common factor, or a GCF. To start, we're going to recap on why we even talk about this. So let's take a look back at a problem like this. You learned about the distributive property where when you have a quantity being multiplied by another quantity, we can distribute that x to both the a and the b, giving us x times a plus x times b. So this process here is called expansion or distributing. What we're going to be doing is we're going to be starting with something like this, and we are going to take it back to this. And to do that, we're going to look for what we call a greatest common factor. So to help us out, let's start by looking at what it means to be a greatest common factor. Notice in this here that there is an x here and there's an x here. That's what makes it common. Then it's the fact that it's multiplied by a and b here, meaning it's a factor. And it's the largest of all the common factors that we have. So we can take that x out, and where normally with the distributing we multiply through, when we factor a common factor, we divide. So let's take a look at a couple of examples. So notice in this case here, we have a factor of a in both of these terms. Therefore, I can divide an a out of both of them. That a goes on the outside, and then the pieces or the factors that remain stay inside. Now, whether that's a variable or it could be a number, there's a factor of 3 in both of these terms. So that 3 is going to go on the outside, and that leaves us a p from the first term minus a q from the second term. Let's make it a little bit more involved. In this case here, quickly we can identify that they both contain an x. However, if we look at the numbers, notice there's a factor of 2 here. And hidden in this 8 is another factor of 2. So we have a common factor of both a 2 and an x. So that common factor of 2x is going to come out. In this first term, that leaves us just the y minus. And in the second term, we're left with the 4 and the z. Now, if you're ever not sure if this is correct, you can always, again, redistribute the 2x in and make sure we get back what we started with. Over here, hidden in this 15 is a 5, and in this 20 is a 5. The greatest common factor of 15 and 20 would be 5. They both contain x's. This factor here, this term here, contains one factor. This term contains 2 factors. Therefore, they both contain at least one factor. I have one factor of y here, 2 factors of y here, so I can take out one y. Now, what does that leave me? If we take out a factor of 5, that would leave me a 3 here. If I take out one factor of x, that would leave me 1x left. If I take out the one factor of y that I started with, I would have no y's remaining here. Plus, take out the factor of 5, take out a factor of x, and take out one factor of y. So let's come up with some basic rules here. There are 3 basic rules. First of all, you're going to look and ask yourself, is it worthwhile for us to take out a negative? Now, there are different approaches to this. Generally, the approach that I use is that if I lead with a negative, then take it out. And you'll see in the next example where I'll do that. Then I look at the coefficients. And again, coefficients are the numbers. and we look at the GCF there. And then finally, we look at the variables, which again are just the letters. So here we are with some more complicated examples. And I start and I look. If my polynomial starts with a negative, then I'll take that negative out. And you'll see why when we get to the end of this, why it might be beneficial. Then I look at the numbers, the coefficients. I have a factor of 3 here. I have a factor of 3 here. So I'll take out the 3. Here I have 3 factors of A. Here I have 2 factors of A. So I can take out 2 factors of A. 2 factors of B here, 4 factors of B here. I'll take out 2. And again, we're dividing, so negative divided by negative gives me a positive. 3 divided by 3 is 1. I had 3 factors of A. We're taking out 2 factors of A. That leaves me 1 factor of A. Here I had 2 factors of B. If I take out 2, it leaves me nothing. Now again, positive divided by negative gives me a negative. 9 divided by 3 is 3. 2 factors of A, take them out, that leaves me no factors of A. 4 factors of B, we took out 2 of them, that leaves me 2 factors of B. In this example, notice we don't lead with a negative, so I'm not going to take a negative out. So I can look at the 12 and the 18, and the GCF would be 6. I look at my M's, and I can take 3 of them out. I look at the N's, 1 here, 1 here. I can take out 1. 3 P's, 5 P's, so I can take out 3 P's. That leaves me a 2, 1 M, no N's, no P's, minus 3, no M's, no N's, and 2 P's. And one thing worth mentioning here is notice, in the end, I should have nothing in common between all the terms that are left inside. Nothing in common. One more example. Again, we lead with a negative, so let's take it out. The GCF of 40, 24, and 16 is 8. I have 2 W's, 1 W, 3 W's, so I can take out 1 W. I have 1 X here, 2 X's here, no X's there, so there's no GCF for the X's. I have 1 Y, no Y's here, so there's no GCF for the Y's. Negative divided by negative is positive. 40 by 8 is 5. We took out 1 W. That leaves me a W here, and we didn't touch the X's or the Y's. Positive divided by negative is negative. 24 divided by 8 is 3. I took out the W, and I didn't touch the X's. Negative divided by negative is positive. 16 divided by 8 is 2. Took out 1 of the W's and no Y's. And again, a quick check. I have a W here, but not here. I have an X here, here, but none there. And I have a Y here, but none here. So that's it for the common factors, and that's it for this lesson.